In most of our lives, we are happy dealing with day-to-day numbers, and it's rare that we encounter those used in science or electronics. In electronics, there can be a wide range. We can have large numbers, such as that used in a resistor, 100 million ohms, 100 megohm, or a small capacitor that could be 12 million millionths of a farad, or 12 picofarads. Often things can happen quickly, perhaps in 40,000 millionths of a second, or 40 nanoseconds. We don't need to be daunted or confused by these numbers, and here we will learn how to control them and in the process make fewer mistakes in dealing with them. It all starts with the dancing decimal point. We normally omit it when we're writing a number. I don't buy 4.0 bananas, but here we will always use it. We will also multiply it by 1, and let's face it, there's nothing simpler than multiplying by 1. So let's confuse things and write it as 10 raised to the power of 0. It looks complex, but any number raised to the power of 0 is 1. Now don't worry about the maths, this is only notation, a way of writing things down. It's not something you can calculate, but like a lot of maths, it's easier if you try to see the patterns. So, 4 can be written as 4 times 10 to the power of 0. 40 is 4 times 10 to the power of 1. Oh, and there's another thing. Any number raised to the power of 0 is 1, and any number raised to the power of 1 is itself. Let's continue with the sequence and see the pattern. 40 is 4.0 times 10 to the power of 1. 400 is 4.0 times 10 to the power of 2. 4,000 is 4.0 times 10 to the power of 3. Working back the other way, 0.4 is 4.0 times 10 to the minus 1. 0.04 is 4.0 times 10 to the minus 2. 0.004 is 4.0 times 10 to the minus 3. And 0.0004 is 4.0 times 10 to the minus 4. Now this may appear to be unnecessarily complex, but stay with it. It does have advantages, as we will see soon. It's our aim to convert any number so that we are left with just one digit in front of the decimal point. This is known as the standard format. Each time the decimal point bounces to the left, we increase the power, or the exponent as it's called. Each time the decimal point bounces to the right, we decrease the exponent. This can be done with any number. Let's see two examples. Take a copy of this large number, stick a decimal place behind it, and multiply it by 1, which in our new method here is 10 to the power of 0. Bounce the decimal place to the left. Count the bounces needed to get to the standard format and record the count in the exponential. Increase the exponent for each bounce to the left. It's the opposite for small numbers. Multiply by 1, 10 to the power of 0. Bounce the decimal point to the right and decrease the exponent until you get to the standard format. Easy, eh? So why have we done this? Standard format is a convenient and therefore less error-prone way of dealing with very large and very small numbers. If you don't like multiplying large numbers and find it easier to add, then try this trick, 300 times 600. Convert to a standard format to make 3 times 10 to the 2 times 6 times 10 to the 2. Multiply 3 times 6 to give 18 in the normal way, but, and here's the important bit, just add the exponentials. 2 plus 2 is 4, giving 18 times 10 to the 4. Move the decimal place to make it into standard format, and there's your answer, 1.8 times 10 to the 5. Job done. Of course, you can always unwrap this to get back to the normal number, but why? This is an acceptable and correct answer. Stop the video and try this. 0.000004 times 800,000. 4 times 10 to the minus 6. 8 times 10 to the 5. Multiply 4 times 8 to give 32. And add 5 minus 6 to give minus 1. So, 32 times 10 to minus 1. Bounce the decimal place back once to the left to get it into standard format. It may be easier to think of it as when the decimal point moves to the left, the number is getting smaller, so the exponential balances by getting larger or more positive. If the decimal point bounces to the right, the number is getting larger, so the exponential balances by getting smaller or more negative. Get used to double checking that positive exponentials are big numbers and negatives are small numbers. So in this video we have seen that any number can be converted into standard format to make dealing with very large and very small numbers a doddle. Standard format has one digit to the left of the decimal place and is multiplied by 10 to the power of a number known as the exponent or exponential. When multiplying standard format numbers, we multiply the small, easy to handle numbers and then just add the exponentials. Patterns help to explain otherwise confusing mathematical notation and what negative exponentials mean. Any number raised to the power of 0 is 1, and any number raised to the power of 1 is itself. Two facts that surely are going to become useful one day. Now, go and multiply the speed of light by the size of a sulfur atom.